Um, I changed my mind. I want to like change the order, right? So let's jump to the midterm data first before I go back to this complicated group operation because I'm afraid that after I do this, you will like get very confused. Okay, so yeah,
I have a question. If I have a data frame, can I like apply all of the deploy function directly to that data frame?
yes,
Oh.
yes, you can apply dplyr function to data frame.
Do I have to use the library function to call the deployer? Like
Yes,
library.
yes, yes. You need to include the data frame. You need to uh, load the dplyr package either by library or by pload function.
So if I didn't load the deployer, then I couldn't do anything. For example, I couldn't use the
Correct. If you do not load the dplyr library, then you cannot use dplyr functions. Okay. Okay. Let's do it this way in the reverse order, right? As I told you that when is our midterm? Uh, Anyone has an idea about which week we will have a midterm? It should be in week 9 or week 10, some here, right? So because we will have a day, we will have a holiday next week. So when you get back, we only have like 2 or 3 weeks left before we have our midterm presentation. Okay, so I would. Um, well, that's worry about that later on. Okay, I would like to teach you enough of things before you do your presentation, right? So today I'll give you the data first, okay? And before you can like look into the data and find out the insight, you need a few technique. First of all, you need to do data processing, right? And that's why we learn dplyr, okay? And you need to do some after you find the insight, you need to do some presentation, right? So you need some plotting technique that will be covered in our next class, okay? And then combining the two, you look into the data, you should be able to like try to explore the data, find out the uh, business insight, and present the insight with some graph, right? And that is basically our midterm presentation, okay? By group, okay? So today let's take a look at the data first, okay? Uh, the data and also the reference notebook are in the Tafand Tafand folder. Okay, Tafand is actually a retail store in Taipei City. Okay, it's a retail store in Taipei City, and the 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 data is already included in the data folder. Okay, so Now let's take a look at the first notebook. The first notebook prep is for data preparation, okay? And we are basically preparing the data with dplyr, okay? All right, so before anything, let's load the data first, okay? So actually, this is not loading data yet. It's just load some package. As you can see that I load the dplyr package, right? Okay. And then I read in the data. Oh, sorry. Okay. As you can see that after we read in the data, we will have 81,000, right? 81,000 row and 9 columns, okay? Let's take a look at this data. Well, this is, okay. Now, you can see that there's a date, and this is the customer ID, and this is the age range, okay? And of the customer, okay? So it has a, this is actually transactional data, okay? So every record is a transaction item, okay? This is the transactional data of that Tafang retail store, okay? And every record is a transaction item, okay? So this customer, at this day, this customer, his age is this, okay? It's between 45 and 49, and the area is actually area code of that customer, okay? This is the category code. Retail store, there are a lot of product, right? And this is the product category, okay? It's only the code, right? The product category. And this is the product ID, okay? So this is the category of the product. This is the product ID. And this is the quantity, okay? And this is the cost of that merchant, okay? Of that product, the cost. And then this is the price. See that? Okay. So every record is actually a transaction item. It's not a transaction. You go to the retail store, you buy a lot of items, right? At a time, right? So every item, you buy something in 7-Eleven, you go to the post, you like scan the code, right? Every scan will produce one record. So if you buy 5 items, okay, you will have 5 records here. Because every item has a product category and product ID, right? So if you buy 5 items in a day, then actually that 5 items actually only represent one transaction. You get me? Okay? So every record is a transaction item. And several items were aggregated into a transaction. Right? Okay? And every customer, if they are repeating purchase, right? Then they will have a several, it will have several transaction. See that? So this data when we have the post data, this is the typical post data, right? I told you that every scan will produce a data, right? So this is a real business data, okay? Real business data. But they are structured within this data, right? Within separate item would aggregate it into one transaction, okay? And separate transaction should be aggregated into one customer, okay? So in the beginning, before we can do anything, right, we need to find out, right? We know that there are so many transaction items, right? So how many transactions do we have? How many customers do we have, right? Before we can do any further exploration, right? We want to process the data so we can see that, so we can organize the data in this way, right? Item within transaction, transaction within customer, right? That is the first thing that we need to do. And we are doing this in this notebook, okay? With dplyr mostly. Question?
So, the same customer can repeat several times.
Right, right. He can buy several times. And every time she buy, she can buy several items, right? And we want to see this structure first, right? Before we can do more, examination. Yeah.
Also, if they have the birthday, why is the age in limits and not the exact age?
Well, this is the for some privacy reason, right?
Okay.
You cannot actually disclose. You don't want to disclose the age of a customer, right? So it only give you the age range. It's not the exact age, okay? And the area code is actually reflect to the area code in Taipei City, right? Question? Okay, so this is the data, right? And this is the data we are going to use in midterm as well as in final.
Same data.
对 same data, right? Okay. So it looks simple, right? It's just only one data table. But along the course, you will see that we can do a lot of things. A lot of things, a lot of analysis with only this data. Okay. So first of all, after reading the data, we can see that the number, well, this is the item, right? Okay. So before anything, we do a data conversion, right? As I told you, right? The data, originally the data is in a character string. We need to translate it. We need to transform it into a digital date, right? Before we can use it in the program. So we use this to transfer the date, and after we transfer the date, we can actually like do a histogram, right? See, so you can see that the period is not too long. It's just from November to the end of February. So we only have like 4 months of data in total. Okay, 4 months of data. Okay, so this stores actually make a big business, right? Within the 4 months, it already have like yeah, 817,000. Yeah, 817,000 transaction item. Okay. Now, and this is the age group and the area. Okay. So as we can see that this is the map of Taipei City. Okay. For those who can read Chinese, you can see that very clearly, right? It's in the area code, okay? And then, so if you see the H group and also the area code distribution, you can see that. So you can see the major customer group, they are of age. They are in the 39 age group, okay? And most of their customers are in 115 and 221, which is here, okay? So we can we can infer that the retail store, maybe some may locate it here, okay? Okay, now we want to handle some outliers. When you deal with the when you are dealing with the real data, you need to do some cleanup. Okay, sometimes there will be some unreasonable outlier data within your data set that you need to like exclude them. Otherwise, the outlier will like distort the entire the entire balance in your analysis. Okay, so first thing that we get the data, we want to like this is to find out the quantiles of quantity, cost, and price, right? Okay, if we see the if we take a summary of Z, sorry. See, the price could be as low as 1 and could be as large as 444,000, right? Now, in a retail store, it's very unreasonable, right, to buy an item of like 444,000, isn't it, right? So it's unreasonable that you are buying something in a quantity of 1,200 in retail store, right? So this is not a normal data, right? So from time to time we want to like exclude this data before we do further analysis, right? So that's why I'm doing this, right? This quantile function, like actually it say that if I want to exclude the like 99.9% of our data of the quantity is below 14, right? 99.95% is below 24, right? Okay, so so actually I'm using this, right? I exclude the 0.05% data and treat them as outlier. Okay, the quantiles actually try to find out that look at this column. It means that 99.95% of our data, right? The price is below 4,000. Okay, so whatever larger than 4,000, I don't want it, right? So this is the thing, right? I subset the Z data set so that the outlier is excluded before anything. Right? Now, the data we have, so at this point we have the data of like how many? So up to this point of time, our data reduced to 7171A2, right? Okay. But this is actually, within this Z table, it is actually a item, right? It is not transaction. As I say that a transaction can have several items within one transaction. But unfortunately, within this the raw data, there is no transaction ID, right? Usually there will be a transaction ID or invoice ID or something like that, right? So, but for some reason, this data set, it do not have a transaction ID, right? So, so we need to do this. We do a group index, okay, by day and customer. Because we do not know we do not have a explicit transaction ID, right? So we kind of treat that every item that the customer buy within a day is in a transaction. That's reasonable, right? Okay? Because we do not have a invoice ID within our data, right? So we kind of treat every customer, every item that the customer buy in the same day, and as a transaction ID, right? This function is actually generate the ID for you, okay? And the way that it works is that for every customer, every item that he buy within the day, there will be a unique transaction ID assigned to it, okay? So in this way, I create a TID column within Z, okay? See, this is the original Z data, and in this comment, see, I create a ZID, right? Okay? So every ZID is actually a transaction. See that? You get the point? Okay? Per customer per day, I treat it as a transaction. Okay? So every transaction has a unique transaction ID. Okay? So now if I want to see the I'm applying n distinct, right? It's number of distinct value in custom category, product, and TID, right? So what does it mean? It means that we have so many transactions. Okay? See, Z, this is the item, right? So the data set has A17,000 items, but they only have 119,000 transactions, right? Which means that each transaction in average, has about 8 items inside, okay? So this is not like a 7-Eleven. This must be something like carry forward, that type of we say 量贩店, right? Okay, it's kind of like a grocery store, okay? So every time you go there, in average, you buy like 7-8 items, right? Okay, thing like that. And this is the number of customers. Because I'm applying n distinct, right? So within all of this item, I see so many customers, okay? Creating so many transactions, okay? And we have so many product category, so many different products. See that? Okay? So this is the power of S apply, right? Because I actually select several column and apply n distinct, so we see the situation, right? Now the data right now, we are like extracting information out of the data, right? We want to have before we do anything, we want to have a holistic idea about the store, right? So within this 4 months, I see 32,000 customer. I see, and each customer is buying in average like less than 4 times. Okay, they are buying in total. They are generating about 119,000 transaction, and in average, every transaction has about 8 items inside. So you have, right? You have some picture coming up already, right? You know the time, you know the space, you know the product, you know the number of customer, you know the number of transaction, you know the transaction per customer, you know the item per transaction. See, right? That's how we begin to do business analytics. Okay. Now we can see the power of dplyr here. Okay. This is the reason that we want to learn dplyr, and this is the reason that we use dplyr in business analytics. Right? Now, for every transaction, so far we only have a table called D, right? Isn't it? And now I group by TID. TID, remember, it's the transaction ID. Okay? So, and I summarize it. Okay? Now, date. Because we know that for every TID, there's only one date. Right? Okay, so, I can choose the... And there's only one customer. Right? And that customer should have the area... That is to say, this four column should be should remain the same within the transaction, isn't it? The date and the customer and the characteristic of the customer should be the same, right? Because they are the same transaction, which is defined by unique date and customer, right? So this 4 column should be the same. So I simply use the minimum. Okay, of them, right? And this should extract the date, customer, and customer's age and area. Okay? And now, items, what does it mean? It means the number of items within this transaction. Some item have a lot of transactions. Some transaction has a lot of items. Some transaction may have only one item, right? And this is the total quantity, okay? And this is the total revenue, okay? And this is the total marginal gain. Because this price minus cost is the margin, right? It's the profit, right? Of course, this is the raw profit, okay? So I sum all of the items price. So this is total revenue created in this transaction. This is the total gross margin generated from this transaction, right? So see, in this group by and summary, I basically transform Z, which is one item per acre, right? I translate it into X, which means transaction, right? So the X, as you can see that, after I transfer it, I translate it into a data frame, and it has 119422 transaction. Okay? So that 800,000 item is converted into 119,000 transaction. And this is actually a typical group by summary. Okay? And in this summary, I actually take a lot of useful information within that transaction. See that? You get the point? Now? Okay? So, and then again, in this transaction label, we also need to handle the outlier, right? Some transaction might not be reasonable, right? So we exclude the unreasonable. Transactions, okay, and then we can see the summary of transaction, as you can see here, right? The date is from November to the end of February, okay? So 4 months of data. Customer age. You can see that there are some, right? This is the range of total transaction revenue, right? The average revenue per transaction is like 851, okay? And the minimum and the largest after excluding outliers. If I do not exclude outlier, you will see that there could be some several million here, but that is not reasonable, right? Yeah.
Professor, do the double hashes mean anything? Or is it just, do they have meaning?
I don't think they mean anything. It just in the R notebook, right? This is just the format that it just means that this is the output of this code chunk. It just means the output of the code chunk. Okay. So if I want to see the transaction number per week, okay, this is the transaction number per week, okay, you can see that. So for some reason, it seems to have a week around. In the last week of December, it actually has a very low number of transactions for some strange reason. Right? Christmas, in Taiwan we don't really have a Christmas holiday though. So, but this is the number of transactions per week. Okay, now we have transaction data. The next thing is we want to examine the number of customers. Right? Because from here we know that we have 32,000 customers generating 119,000 transactions. Okay? So in average, every customer like generate like 4 transactions. Okay? So we want to, like, from X, again, we want to do a group by. See that? We group by customer, and then, again, we summarize this RFM. R means the recency, which means that how many days this customer, since this customer last time buy from us, how many days, right? From the last date of the data.
Difference between the last date and today.
Yes, as you can see that I'm calculating difference. I mutate the column called days. See that? Okay. And I use the maximum of date plus 1, right? So usually when we calculate the recency, we want to use because the period is at the end of February, right? So I count the difference between the date with the March the 1st, okay? You got the point, right? It's if I use today, it's not make sense. Do not make sense, right? So after I gather the data, I use the data plus 1 to calculate the days, right? And as you can see that this is the minimum days because a customer can buy from you several times, right? So I only want to see the last time that he buy, right? That's the most recent record that he buy from us. And seniority is like the maximum days, right? And this is, F is the frequency, the number of time he buy from us, the number of transactions generated by this customer, right? The monetary is actually the average. When this customer buy from us, what is his average transaction amount, right? Okay. So we know how frequently he buy from us, right? When is he, how recent he buy from us. We know how frequent he buy from us. We know that when he buy from us, how much he will buy. Okay, for every customer, I'll know this information. And this two column is actually the characteristic of that customer, right? The age and area code. And this is the total revenue and gross profit contributions. Okay. So now we have up to this point. Let me run this. Okay, so up to this point of time, we will have 3 data frame. Okay, Z is the original data, 1 record per item, right? And X is the transaction data. So each record represent what? In X, what is a record represent? Z represent the item, right? And X, what does the record of X represent? Represent a transaction, isn't it? Right? A transaction. Now, what is a record in A represent? Here you group by customer, right? That's why we use group by and summary to aggregate data into the labels of our interest, right? Isn't it? Okay. So if I want to see the age group, now this number is actually the number of customer, right? See, in total I have like 32,000 customer, and the largest age group is A39. Okay, so it has like about 7,000 customer, right? Is there, right? And the same thing is that the same thing apply to area, right? So most of our in which area do we have most of our customer? 115. So how many customers do we have in that area?
Around 10,000.
Yeah, around 10,000, right? Isn't it? See, you get the data, and then you are using this data to understand your business, right? That is the first step of business analytics. Okay? And then, now this is the RFM. Okay? Let's just look at here. It's easier. So this is the distribution of R. Right? So, so as you can see that most of the people, the residency is like within 20 days. Okay? So the customers are active, right? Which means that these customers are active. They are buying from us recently, right? And these people are not. Okay? It's like they buy from us like 120 days ago and never come back, right? This type of customers like that. Now this is seniority, right? Now seniority in this case do not mean anything too much because we only have 4 months of data. Okay, so we skip this one. This is the frequency, right? So most of the people is buying like so frequency is actually a numeric, right? So every bar represent 5, right? Because this is 20, right? We have 4 bar before 20. So this is the from 1 to 5. This is from 6 to 10, thing like that. So most of the people is buying like 1 to 5 times, okay? And then it decreases very quickly, right? Very few people are buying more than 20, okay? But there are people buying like 80 times, okay?
This is 80 items in one transaction, or 80
No.
times in the past 4 months.
No, this because we are doing this from A, right? So we are talking about this customer. We have one customer here, right? That one customer is buying like 80 times in 4 months.
80 times.
Yeah, that one customer is buying 80 times for 4 months. And this is the distribution of money, right? So you can see that now each bar is how many? Can anyone see? 1,000, right? Because and so most of the customers, the average buying amount is like within 1,000, right? You can see that, right? And I tell you that actually, if we want to see it better, we can. If we want to see the distribution better, we can apply log, right? So most of the time, when you are looking at the real transactional data, you will see a distribution like that, and for business reason, usually we'll apply log 10, right? So for log 10, that 1 means $10. Here is 100. Here is 1,000, and here is like 10,000. You can see that. So the distribution is easier to understand the distribution. So now after we it would be a good practice, right? Because it takes us a lot of time to do the clean up the data and manipulate the data into the way we want, right? So we have better set the data into our data file. So next time we just load the data. We don't need to process the data from scratch, right? So set the data. Okay. So with this data, we can do a lot of things, right? So we would like to explore how consuming behavior varies by age and by age groups, right? The average buying amount or the buying frequency could be different in different area, could be different in different age group, right? You might want to see that how the buying behavior varies within the customer groups, right? between the weekday and weekend, customer might not behave the same way, right? In the weekend, they may have some product they want to buy. In the weekday, they might buy some other products. Okay, so although we only have one data frame, okay, although we only have one data frame, but actually we can know a lot of things only by looking into this transactional data. And that is the power of business analytics. Okay? Let's get back to it's 11:58 already. So let's go to today's assignment. Okay. Now we already have that actually I already covered I do not have time to go through this group operation in detail yet, but I think that does not matter, right? Okay. The first personal assignment, because we have 2 weeks, right? So I want you to do a data camp online course. Okay. It's called Data Manipulation with dplyr in R. It uses exactly the same data frame that I'm using, the county data frame. Okay. So it would be like after our class, it should not be too difficult to follow that. And the thing that I do not cover should be covered in that in that online course. Okay. So upload your certificate, right? After you finish that, you should have a certificate. Okay. So you can download the certificate and upload it to this directory. That is your personal assignment. Okay. And there is a group assignment, right? I want you to like do this together, right? Go through the TF1, which is this notebook. Okay. Make sure that you get together and understand the command. Understand all of the code and the reason that I want to do a data preparation, right? And think about what you can do with this data. Okay? Now you have customer data. Now you have transaction data. Now you have item data, right? So product-wise, what can you see? Customer-wise, what can you see? Try to use the technique that you have learned in the car stolen case. Try to use the technique that you have learned in the census cases, right? Try to find some insight out of the transaction, out of customer, especially for customer, because that is important, right? And remember that customer can be grouped into age and what an area, right? Okay. So first thing of business analytics is to do group categorical statistic and do group comparison, right? First of all, you want to know the in a holistic view, you want to see the summary of your business, right? And then after you know the summary of your business, you want to see the behavior of each different group. the behavior of different product category, the behavior of different date, weekday, weekend, the behavior of different customer, right? Customer from different area, right? That is the thing that you can explore within the data, right? I want you to, as a group assignment, I want you to explore the data, right? With whatever you have, right? And then put it in a assignment and then upload it to here. See that? That is your group assignment. See that? So do your personal homework and upload the certificate and get together, and by using the data that we already prepared, try to do some exploration, okay? And put the exploration, put the find out of your exploration on that notebook and upload it as your homework, okay? Actually, I will, if after you upload the data, I will look at them and I will pick one group and I will give you a prize for the team that get the most useful insight out of the data. Okay? Question? Okay, and that's all for today. I'll see you in 2 weeks. Okay? Bye-bye.